Exponential function. Exponential function is a type of function in which exponent, yeah, variable present in power. If we take, for example, 2 power x, so x is a variable and variable present in power. We have 10 power x, so 10 power x, actually x is a variable and variable present in power. Yes, already session recorded, Nagina. So we have a function f of x equal to, we can write b power x, where b is base, it's a constant number, and this b must be a positive number. But this b is greater than 0 and b not equal to 1. 1 is not possible, because if you write 1 power x, so if you give any value, result will be 1. 1 power 100 equal to 1. So b not equal to 1. So that function is called what? An exponential function. Uh, you can see the f of x is equal to 2 power x. X is in power. We have second f of x is equal to 5x minus 2. So x we have in power, and 9 power 2x plus 1. So we have 2x is power. So when we have a variable in the power, that function is called an exponential function. But there are conditions that base is greater than 0, it means 0 is not possible, negative value not possible. Second condition, b not equal to 1. uh, Decimal value possible, like 0 0.2, 0 0.5, 0.5 power x, or fraction value also possible, 1 over 2 power x. That function is called exponential function, and it very important and have a wide range of application in daily life, in business, in other engineering. So we will discuss today about the exponential function. First, how to draw the graph, then how to find domain and range, and then we will discuss how we can find the exponent, how we can find the x variable, yeah, x value. First, we have graph of exponential function, and there are two types of exponential function. One exponential function. Okay, okay, you are present. So first one, you can see first graph is f of x is equal to 2 power x. 2 power x. Here base is greater than 1. 2, 3, 4, 5 values. Second function, second graph, we have 1 over 2 power x. And you can see base is greater than 0, but base is actually less than 1. 0.1 over 2 means 0.5 power x. So first step, first part, 2 power x, when base is greater than 1, this function is called exponential growth, because it's increasing function. So we call this as exponential growth. Second function, b is less than 1, or 1 over 2, or 0.5, and the graph is decreasing. You can see graph is decreasing. So this function is called exponential decay. Exponential decay. First one, exponential growth means, or where we use exponential function, or what mean exponential growth, what mean exponential decay. Exponential growth means when something increasing very fast, like production of bacteria and viruses increase very fast or very rapidly. Like the production of coronavirus situation, you can see that it's increasing day by day, very exponentially. Exponentially means very fast. Second one, exponential decay means that when something decreasing very slowly. You can see the graph, x values are increasing, but graph is decreasing, and graph is decreasing very slowly. like radioactive decay. If you hear the word radioactive element, actually radioactive elements emit radiation rays. If we, for example, place 1 kg of uranium in element, so after some time, like after 50 years, 60 years, like after 100 years, it becomes 0.5 kg. It means half of original weight. Why? Because it's emitting radiation. And when it emits radiation, mass is decreasing. And that, for example, duration in which one element remain half of its original element, it's called half-life of that element. But it takes 100 years, it takes 50, 60, 70 years. So when something is decreasing very slowly, that's called exponentially decay. And when something increasing very fast, that's called exponential growth. And condition for exponential growth and exponential decay is when base is greater than 1, that's called what? Exponential growth. When base is greater than 0 but less than 1, it means in between 0 and 1. So that's called exponential decay, and that will decrease very slowly. Okay, there are some properties of exponential function. uh, you can see these two graphs. One is, first one, it's exponential growth. Second one is exponential decay. So what are the similarities between both? Both have domain all real numbers. If we take 2 power x, or if we take 1 over 2 power x, so both you can give any value. The domain will be from minus infinity till plus infinity. You can give, for example, 2 power x. If you give plus value, 2 power 1 equal to 2. If you give negative value like 2 power minus 1, so 2 power minus 1 we can write like 1 over 2, and 1 over 2 is equal to 0.5. It will always give you positive value as well. Giving negative value, result is 0.5 if positive. If you give, for example, 2 power minus 2, so then we can write in the form of 1 over 4 or 1 over 2 power 2, 2 power 2. And 1 over 2 power 2 means 4, 1 over 4 means 0.25. Giving positive value will result positive output. Giving negative input also give you the positive output. So this means that range is always positive values. 0 is not possible greater than 0. Range is from 1 till plus infinity possible. If you give negative value positive, result is always positive. For example, if you give 0 value, 2 power x, so 2 power 0, 2 power 0 means 1. It will never, yeah, no real value equal this function equal to 0. So always 1 and greater than 1 possible, 1 till plus infinity possible. Okay, next we have graph. In both graph passing 0, 1 graph. This one is 0, 1 means the y-intercept. So you can see here both location. This location is 0 and 1. This one 0 and 1. For example, if we take uh, 10
So it
power,
will always be pass at 0.1.
yes, yes, I'm talking about base function. Then I will discuss. If you shift, then it will shift upward, downward possible. But if we have base function 10 power x, so 10 power x, actually it will pass what? It will pass from 0, 1. If you give x is equal to 0, so 10 power 0 is equal to 1. X is 0, y is 1. Same second one condition. If we have 1 over 2 power x, so again if you put x is equal to 0, so 1 over 2 power 0 and 1 over 2 power 0 is equal to 1. X is 0, y is 1. This is the base functions. a power x or 1 over 2 power x or 2 power x 10 power x. Shifting also possible, if you are given a function like b y is equal to b power x. So if you want to shift the graph, so if you add plus 2, so then graph will start from 3 because b power x is 1 plus 2 means 3. So we have 1, 2 and 3, then graph will be like this one. If you add 5 here, so then graph will start from 7. Same if you give the value minus, so it will shift downward. Same about the second type of function 1 over 2 power x, the graph will pass from 0 1, but if you add 1 here, so then it means that graph will move upward. If you add 2, so then 2 unit upward. When you add 3, then 3 unit upward. So shifting possible, but base function actually it will pass from 0 and 1. And I'm talking about these two graphs, the similarities of these two graphs, that in these two graphs the both y-intercept is equal to 0 1. Next one, uh, next similarity between these two graphs is actually asymptote for both graph is x-axis. You can see this graph. This graph is moving closer and closer to x-axis, but it will never touch x-axis. Same this one. This graph is also moving toward x-axis, but it will never touch x-axis. For example, if we have 2 power x, if you give like negative values, so 2 power minus 1 equal to 1 over 2, and 1 over 2 is equal to 0 0.5. We are giving values, we are giving minus values, and you will see that the values are decreasing, but it will never become 0. Like for x is equal to minus 1, result is 0 0.5. If you give x is equal to 2, so 2 power 2 means 2 power minus 2, we can write in the form of 2 power 2, or 2 power 2 means 1 over 4, and 1 over 4 means 0.25. You can see first one 0.5, second one is 0.25. It's decreasing, but it's not going 0. It will never go 0 video. Like if we have 2 power minus 3, 2 power minus 3 means 1 over 2 power plus 3, and 1 over 2 power plus 3 means 1 over uh, 8. And if you divide 1 over 8, so result will be okay, 1 divided by 8, 0.12. You can see this is reducing. First one is 0.5, second one is 0.25, third one is 0.12. It will reduce like after this 0.8, 0.6, but it will decrease and it will never become 0 because the range 0 is not possible for exponential function. In this, the graph will never touch 0 x or x-axis. So x is actually the asymptote of exponential function. I'm talking about these two graphs. These are
Excuse me, Professor.
yes,
I have a
yes,
question.
yes, yes.
So, if it can be zero, can it be a minus a negative number?
If we have this function 2 power x, so for this function 0 is not possible. Okay, negative values are possible. So then graph will start from negative. If we draw here, let me draw. Okay, let's suppose I want to draw graph here. So if on right side graph is like this one, it's moving toward the 0, but it will never touch x-axis. So if you give negative values, so graph will be same, but it will start from here, like this one. So on both sides, it's moving toward the x-axis, but it will never touch x-axis. Negative value possible. Only 0 is not possible. Clear?
Got it,
Okay.
Professor. Thank you.
Okay. So, difference between these two, first one is actually increasing function, this one. This is the difference. This is increasing function. And second one is called decreasing function, it is decreasing. In first case, x values are increasing, y values are also increasing. Second case, x values are increasing, but y values are decreasing because this graph moving downward. So these are actually the difference between these two graphs. Okay, first one is called exponential growth. Second one is called exponential decay. We will discuss some problem on what is exponential growth and what is exponential decay. These are difference and similarities between these two graphs. Now, general the exponential function properties, characteristics. So characteristic of exponential function is domain from minus infinity till plus infinity. Range is always a positive value, 0 to plus infinity, but 0 is not included. And its graph passes through 0 and 1. Second one, it's continues from minus infinity till plus infinity. In graph, there are no breaks. First, first one, this is increasing when base is greater than 1. Second one, when base is less than 1, so this is called decreasing, and it will decrease from minus infinity till plus infinity. Okay, there are some exponent rules, law of powers, law of exponent, and I think you studied these in maths 9-8, but I will give you a brief review of law of exponent. First rule is actually product rule. When we have, for example, two number, 2 power x multiply with 2 power x. And first rule is in product, when bases are same, then power should be added. For example, we have 2 power x, 2 power x. So take 1, 2 and add their power x plus x. This means that 2 power 2x. Or if we have 10 power x, then multiply with 10 power 3x. So bases are same. Take one base and add their power x plus 3x. So 10 power 4x. Right. This is first rule or product rule. We have second rule. Second rule is actually uh, we have uh, quotient rule, division rule. For example, when two numbers are divided, like in division form, we have a power x and b power x divided by a power 2x. So in division, when bases are same, both are a, so then subtract their powers. Take one base and x minus 2x. Subtract their power. For example, if we have 10 power 10x divided by 10 power 2x. So in division, when both bases are same, take one base and subtract their power. 10x minus 2x equal to 10x minus 2x equal to 8x. Okay, third one is actually power to power rule. Power to power.
Professor,
Yes,
a question.
yes.
So if the exponent becomes a negative, is that okay?
Sorry, I can hear you clearly. Yes.
I mean, if the exponent become negative,
Can anybody tell me what she asking?
okay.
Can you hear him, guys? Sorry, can you hear her?
No, sir.
No, no.
No,
Because
sir.
because I can hear.
I think she is writing in chat.
Okay, okay. Okay, if exponent become negative, so same you can subtract, like if we have 2 power 2x divided by 2 power, let's suppose minus 3x. So then take one base and subtract their power 2x minus, and then we have minus 3x. So 2 power 2x plus minus minus become plus 3x. This means that 2 power 5x, or both are minus, like one is 5 power x minus x divided by 5 power minus 2x. So same, take one base and subtract their power minus x minus 2x. So we have 5 minus x plus 2x. Minus x plus 2x is 5 power 1x, because 2 minus 1 is equal to x. Clear for us now? Okay. Next we have power to power. When we have 2 power x and whole power 2. Thank you. So we have two powers. So power to power rule, multiply powers. Okay, so take one base and multiply x with 2 equal to 2x. Or if we have 10 power 2 whole power 5. So take base and multiply power, 2 multiply 5 equal to 10. This is power to power rule of exponent. Then we have a multiply b power x, like this one. If we have 3 multiply with, let's suppose, x, and we have power 2, so this power is actually for both. If you want to expand, so you can write 3 power 2 and x power 2. Power is for both. For example, if we have 10 power x and also we have 5 power 2 and we have whole power 4. So this 4 is actually for 10x, and this 4 is also for 5 power 2. So we can write 10, 4 multiplied with x is 4x. Then we have 5 power 2, so write down 5, and 2 power 2 multiplied 4 is equal to 8. So this is an expansion form. You can expand when we have a combined power. Again, if we have a b power x, so this power is for both. You can write a power x and b power x. Next, fourth one, fifth one actually. Fifth one is in quotient form having combined power. We have fraction in combined form, like a divided by b whole power x. So this whole power is for both. You can write in expansion form a power x divided by b power x. Or if we have 2 over 5 and whole power x, so this means that this x is for both. You can write 2 power x and you can write 5 power x. So these are actually law of exponent. We will discuss some exercise, some questions on these rules, these laws. First one, if function is given, f of x is equal to 2 power 2x minus 1, exponential function because x is in power. F of x is equal to 2 power, we have 2x minus 1. Also given that f of x is equal to 16. This is f of x value. So how we can find the value of x? So if you replace f of x with 16, and we have 2 power 2x minus 1. Now how we can find the value of x, because x is in power? So there is only there are two methods. One is taking log, and second method is, if you make the bases same, then you can compare the powers. Like we have 16. If we write 16 in the form of 2 power 4, if we write 16 at the base of 2, so we have 2 power 4 and we have 2 power 2x minus 1. Now bases are same. Now you can compare their powers. Write down 4 equal to 2x minus 1. These are powers. So transfer 1 to other side. 4 plus 1 equal to 5, and we have 2x. So if you divide both sides by 2, 5 divided by 2 and 2x by 2. Result is x is equal to 5 divided by 2, the value of x. Next example, uh, same example. For example, we have f of x. Let's suppose we have equation 27 equal to 3 power x plus 1. So how we can find the value of x? X is in power, so two values, two rules possible. One is logarithmic, uh, applying log, so you can find the value of x. Second method is if you can write both sides at the base of 3, or if you can write both sides at the same base, so then it's possible. If we write 27 in the form of 3 power 3, base is 3, and another side is 3 power x plus 1. Now both bases are same, so then you can compare the power. 3 equal to x plus 1. If you transfer 1 to other side, so 3 minus 1 equal to x, or x is equal to 2. 3 minus 1 equal to 2. So in this way, you can find the value of x. If you cannot write second or for example both in same ways, then you need to apply logarithmic. We will discuss log in next week. Next topic is logarithm. Okay, then one another thing. So far we discussed about the constant number like 2 power x and 1 over 2 power x. We have one another form, one another number that's called Euler number E. E is called Euler number, and the value of E is 2.71. You have in calculator E, so the value is the it's like a pi. You know pi, it's a constant number, and value of pi is 3.1415. Or you can write pi in the form of 22 over 7. They have fixed value. Pi have fixed value. Same, E is a fixed number, is a constant number. It's called Euler number, and E is equal to 2.71. And we have many applications at the base of E in business, and we have, for example, in population growth, how we can find population, for example, in Afghanistan. So we use the model. That model contain E. For example, uh, let's suppose we will discuss this growth in decay model. If you want to find the population growth, rate of population growth, let's suppose in Kabul city, so we need this model. And actually, you know that it is very difficult to conduct census in all over Afghanistan. It's very difficult to visit every village, every area. So therefore, we use actually the this model to populate the population of Afghanistan. Yeah, any other country actually they populate according to this model, in which, for example, in which like Afghanistan and other, it's not possible to visit every area, for example, every city, every village, every house. So then they use model, and I know in Afghanistan they use this model to populate. In this model, we have A is equal to A naught e power kt, where A naught, let's suppose this is original population. E, this is base E, exponential Euler number. T means time. K is actually, this is main thing is this one. This is called the exponential constant. This is actually rate of increase or rate of decrease. How we can use this? Let's try. We have actually the avic population on the planet. You can see this animal is called, this is like a teddy bear, called avic. The avic population on the planet has a relative growth rate of 3%. This is actually key video. This is a rate percentage, key video, 3%. Okay, and it's estimated that the population is 6,500. Find the function that model the population in T years. And second one, use the function to estimate the avic population in 8 years. Okay, K value is given. Also, original value is given. We have model A is equal to A naught e power kt. T is time, in this case is rate. Yeah, rate, growth rate, you can say. We have 3%. 3% means 3 divided by 100, or you can write 0.03. Original population is given. Original population is 6,500. So if you put these value in model, so then you can populate after 8 years. Yes, T is unknown, and first T is unknown. So write general model. Second, we are given T, so T means 8 years, so you can replace. For example, first one, A is equal to 6,500 e power k, so k is 0.03 and T is T. This is part 1. We have model. Now in second, T is given, T is equal to 8, so you can write the population after 8 years, 6,500 e power, we have 0.03 multiply with time, and time is 8. A is equal to 6,500 multiply e power, if you multiply powers, so equal to 0.24. 0.03 multiplied with 8 equal to 0.24. Now we have function in calculator e power 0.024. You can write e power x any video. If you check your calculator, yes, thank you. So we have e power 0.24. What's the value of e power? 0.24. If you check the calculator, e power x and e both are given. So use e power x. Then put the value 0.24. E power 24 is equal to 6,500 multiply with 1.27 something. So multiply 1.27 with 6,500. 6,500 equal to 8,263 something. 8263 point something. So after 8 years, the population will be 8,263. Yes, yes. It's not 8 point actually. It's comma. After every 3 digit, we write 3 commas. So it's 8,263.11. Then we have point. Let's suppose if you want to find the population of Kabul city, in just you need what? You need original population. Let's suppose it's 2020 starting here, and the population, the now original population is recent population, you can see, is, let's suppose, 20 million. And you know that the rate of population growth is actually 4% per year. Let's suppose 4%. 4% you can write like 0.04. So what will be the population in 2030? This means that time is 10. So use the model. A is equal to A naught multiply with e power kt. Original is 20 million e power k. This is growth rate multiply with time. Time is actually 10 in 2030. So we have 20 e power 0.04 multiply with 10 is equal to 0.4. Now find the value of e power 0.4 and then multiply with 20. So first of all, we have e power zero point 0.4 equal to 1.49. 20 multiply with 1.49 something. So multiply with 20 equal to, we have 20 multiply 1.49, 29.8. Yes, thank you. 29.8 something. So in 2030, the population will be 29,000 something. These are millions. So uh, key value, when key value is positive, so then it's growth, it's increasing. When key value is negative, then it's decreasing. In question, if given that the growth rate, yeah, for example, the population is increasing 3% per year. Increasing means this value is positive. If given that the increase, the population is decreasing or the growth rate of decreasing, so then you can take negative value. Okay, uh, we have a is equal to a naught k, sorry, e power kt. Let's suppose uh, if original population is given, the original population is 12 million original. Okay, rate is, let's suppose if you say increasing function, so let's suppose this is 5%. 5% means 0.05. Time is given, time is equal to, let's suppose, 20 years. So A is equal to 12 million multiply with e power 0.05 multiply with time, time is 20. So we have 12 multiply with e power 0.05 multiply with 20 equal to, yes, zero point zero 0.05 multiply 20 equal to 1. It means 1.2 e power 1. So we have 12 multiply with, what is the value of e? E is equal to 2.71. You can directly multiply with e in calculator. E multiply with 12. So equal to what? Equal to 32 point something. We have 2.71 multiply with 12 millions equal to 32.5. 32.52 millions after 20. This was the first application of E, first application of exponential function we use for exponential growth and exponential decay. Exponential growth means population growth. When something is, population is increasing. K value is positive, something is increasing. When K value is negative, then something is decreasing. But both have same model. A is equal to A naught and E power KT. Same, we have another application of exponential function, compound interest. Who will tell me about the interest? Simple interest and compound interest. What is simple and compound interest? Any idea about interest if you have business student? Two types. Roba Sudasa. Yeah, Sadasa
Maybe
Murakab.
sir, the
Yes, 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 yes. Simple interest Roba Sada. Compound interest Roba Murakabas. And interest means actually fee for the use of money. If you borrow some money from a bank or a person, so he will charge an extra amount. He will charge an extra profit For the use of that money, that's called what? That's called actually the interest.
Sir, I think compound interest calculate the previous amount of money, maybe.
Yes, yes, yes,
In simple, just the original one.
yes, original one. Uh, Simple interest is actually on principal amount. When you borrow some money, when you take loan from a bank, let's suppose 10,000. So for 10,000, bank will charge every year some percentage of profit. For example, first year 5%, second year 5%, but amount is 10,000. Okay, let me write here. Let me explain. Uh, Simple interest, formula of simple interest is interest is equal to principal rate in time. सरमाया नर्ख और time असता, but time in years. For example, you want to take loan from a bank. Let's suppose you want to take loan of $20,000 from a bank. For how many years? Let's suppose you want to take for 10 years. And bank will take profit. Bank will take charge. Bank will charge profit. Bank will charge fee for the use of $20,000 from the bank. Let's call interest. Let's suppose bank want to take 30% profit per year. So 30%, 3% profit per year. Uh, yes, yes. Okay. So what is interest for 10 years? Let's suppose, okay, I want to divide in one year. For example, first year, what is interest? Principal is 20,000 multiply with rate is 3%, 3 divided by 100, multiply with 1 year, first year. So if you cancel 20 with 20, 200 multiply with 3 equal to 600. So first year he will charge 600. Same in second year, we have formula I is equal to PRT. Principal 20,000 multiply with percentage 3% multiply with second year but 1 year. So again, if you cancel 0, result is 600. Why? Because for first year, for second year, for third, fourth till 10 year, the amount is same, 20,000. He only charge uh, for 20,000, principal amount 20,000. But in compound interest, it is something different. Compound interest is interest over interest. Sood wala sood. Okay, bank will charge uh, interest also for interest. For example, same problem. If we have principal, if you want to take the amount 20,000 from a bank for let's suppose 10 year, and bank will charge 3% profit per year. So what will be the interest for first year? We have PRT. Principal amount is 20,000. Rate is let's suppose 3% multiply with 1. 1 means for first year. So result is let's suppose 600. But in second year, the amount is not 20,000. 20,000 will be added with the interest from the first year, 600. So for next year, for second year, so 20,000 and 600. So then bank will charge the interest on 20,600, interest over interest. Sud balai sud. Then bank will take interest from the interest as well. So that's called compound interest. So when, for example, number of years increasing, the amount is increasing and interest is also increasing. For compound interest, we use formula uh, A is equal to A is amount. This is future video. P1 plus Rn divided by T. This is actually for annual system. When after 1 year the interest combined with the loan with the principal amount. Or when, for example, the interest added with the loan after 6 months, this is called semi-annual system. Then also we have quarter system. After 3 month interest and loan is compounded. We have also monthly system. After each month, loan aid with the interest. Then we have also the weekly system. Every week, the interest is compounded, like loan plus interest. Then that will charge, yeah, bank will charge interest from that. Same we have weekly system. Sorry, weekly system and also daily system. Daily loan plus interest is added and then charge interest from there. But when we have continuous, continuous means daily system. When daily loan is charged, loan and the interest is added. And for continuous interest, we use this formula: A is equal to PE power T. Same like previous model. This is actually original amount E power RT, where R is actually rate and T means time. Or we can also use this for future video, like if you want to invest money in a bank, for example in one business. Let's suppose you have $25,000 and you want to invest this in one business for 10 years, and from that business, profit per year is actually 5%. So what will be your amount after 10 years? A means amount or your future value. Original you invested 25,000 for 10 years. In each year you receive 5% profit. So what will be your 25,000 after 10 years? We use this formula: A is equal to P into E power RT. P means invested amount 25,000 multiply with E power R. Rate percentage 5% means 5 divided by 100 equal to 0.05, and multiply with what? Multiply with uh, time, and time is 10 years. So we have 25,000 E power this one, E power 0.05 multiply with 10 equal to what? Okay, this one is point 0.05 multiply with 10 equal to 0.5, and e power 0.5, e power zero point 0.5 equal to 1.6. We have 25,000 multiply with 1.64. Yes, 1.64 when you multiply with 25,000. So result is 41,000 218 point something. So after 10 years, your invested amount reached to 41,218 point something. That's called continuous compound interest. Okay, okay, good. Okay, good, excellent. What about the Zoom? Timing of Zoom. This is first meeting for us. Okay. So, two application. One is the uh, exponential growth problem, exponential decay problem. Second one is compound interest formula, compound interest. In both variable is in power, but when we don't know about power like r and t, so we need what? We need actually bases must be same, both side bases must be same. R if both bases are not same, then we use logarithmic function. So let's suppose if you are given some condition and you know that like this one, 400 equal to 200 e power r into t, t is 5 r, this one 400 equal to 200 e power 5 r. Now we don't know about the power rate, we don't know about rate. So then condition is make the basis same. If not possible, then we use logarithm, and we will discuss logarithm in next class. That how we use logarithm, what are the types of logarithm, and application of logarithm. Clear?